Okay, in this problem, we review what I call connected objects. So it says that we have a horizontal surface. So I'll draw my surface. And we have three masses that are connected by a string, or by pieces of a string. Alright, so they are pulled with a force of 75 newtons. And instead of calling this an FA, they just happened to call it FT3 of 75 newtons. So we'll label that. Alright, the masses respectively are 3 kilograms, 5 kilograms, and 4 kilograms. And there is friction in our story of 0.3. So I think I'm going to start by finding the friction. So to find the friction, I'm going to do FW. So 3 times 9.8 is 29.4. So that's my FW. And so let's label that FW. And friction is mu times Fn. And my Fn value is going to be the same. So this is going to be 0.3 times 29.4. And I won't show that work for each of the further ones. Alright, so friction on this block, I'm going to draw friction like this. Friction turns out to be 8.82 newtons. So we'll label that as friction. Alright, on the second block, 5 times 9.8 is 49. So FW is 49 newtons. Whoops, 49 newtons. So Fn is 49. So 0.3 times 49. So we also have friction over here. And this turns out to be 14.7 newtons. And here we have FW, that is 4 times 9.8, that's 39.2. So Fn is the same, Fn. So friction is 0.3 times 39.2, and that turns out to be 11.76 newtons. That's my friction. Okay, so to start with, question A says calculate the acceleration of the system, and then they're asking me to find the tension in those respective strings. So they want me to find this tension, which they called T1, but I'm going to call that looks like torque, so I'm going to call it FT1, and I'm going to call this one FT2. So I don't know if you remember this, but you can never find the tension in the string until you know the acceleration of the system. So it makes sense why question A is here. So I'm going to write down F net equals, when you have connected objects, we want to use M net because we're looking at it as a system and we're trying to find the acceleration of the system. So you have to think big when you find the acceleration of the system. So when I say the word think big, you say to yourself, what is making this system move? Well, that would be this pulling force, 75. Minus, what is working against you in this system? Right there, these frictions, friction, friction. So I'm going to have to subtract off each of them. Minus 8.82, minus 14.7, minus 11.76. What makes it move? Minus what you're dragging or what's working against you in terms of forces. All right. Then M net is the mass of everything. So 3 plus 5 plus 4, that's going to be 12. And then I'm going to solve for A. And the acceleration is 3.31 meters per second squared. All right, to find the tension in the string, we have to draw free body diagrams of each little piece. So I'm going to start way away, or at the far end of what I know. So I'm now going to draw a free body diagram of just the 3 block. So when I come down here and I draw a picture of the 3 block, I look at what's on the 3 block. I have some FT1, and I'm making the FT1 arrow kind of long because I know it's going this way. And I have friction working against him, so I'm going to write down 8.82. And then I'm going to write down F net equals MA. That's going to be FT1 minus 8.82. The mass of this block is 3. And the acceleration we just found of the whole system, every piece of the system is moving with that same value. And FT1 turns out to be 18.75 newtons. When I move on to the next block, I'll switch colors here. I'm going to circle this now. It's a little bit more complicated. So I'm going to write down the 5. And I have FT2 going this way. I'll make this one a little bit longer again because I know it's going this way. But look what's working against me. I have this friction that's pointing this way. And I also have this other piece of string that's going this way. So I'm going to start with that string. That string is FT1, but we already know the answer to FT1. It's right here. So I'm going to write down 18.75. And we have another arrow going this way. I don't really know. Well, I guess I do know which one's bigger. So this one's 14.7. So now when I write down F net equals MA, I end up with FT2 minus 18.75 minus 14.7 equals M times A. And I can solve for FT2 and we get 50. So when I write these in here now, if this is 18.75 and this is 50, technically I know all of the answers to all of the questions. But I want to show you how that you can look at the last box to check your answer. So when I look at the last box, and I'll skip kind of drawing the picture here, we'll just kind of talk through it. So I see that I have an FT3 arrow going this way, but we know what that answer is. That answer is 75. And minus, we have two things going backwards. We have 11.76 friction, and we have FT2. So 11.76 friction minus FT2, which is 50, equals M times A. And we can just use this as a check, because if this all works out, then I feel pretty confident that everything else on my page is correct. So again, we need to take this idea with us of how to handle connected objects, because you can see that we're going to start to have more fancier connected objects, and then we're also going to have connected objects back on the inclined planes. And if we take our skills and just build them little by little, we just keep adding them on top of each other, and then these more complex problems aren't so difficult anymore.